I'm Joshua Bardwell, and you're going to learn something today because I've got another interview for you with Ryan Harrell. Ryan Harrell of MiniQuadTestBench.com is one of the most knowledgeable people I can think of when it comes to mini-quad motors and ESCs. His site tests motors and ESCs, mostly motors these days, and he's got so much data about how different motors respond to different props and motor construction. Just every time I do an interview with him, I just want to kind of squeeze him like a sponge and see what comes out. And that's kind of what we did here. The nominal intent of this interview was to take the T-motor series of motors, the F40, the F60, the F80, whatever, and break down what makes them different. And we did some of that. But as always with the interview with him, we talked about all kinds of things. And normally I would apologize for not having like a more focused interview, but every time we went on, I was just so interested in the things we were talking about, and I hope you guys are going to be too. This video is a little bit long. It's over an hour long, and for some of you, you're going to love it. I treat this one kind of like a podcast, where you kind of put it on and listen in the background maybe, and don't just stare at our two faces for an hour and a half, however long it is. Anyway, let's get into the video. Well, I wanted to interview you again or talk to you again because I had such a great time in our first interview, and so did everybody else. In fact, it was hugely popular. And if anybody hasn't seen the first interview, nominally it was about the Emax 2306 motor, but when we got in the same room, we just started talking about motors, and you're such a fount of knowledge. There are people who are so deeply knowledgeable about a topic that just the sort of crumbs that fall off their plate are just like, when it comes to motors, I hope I'm not making your head too big, but you're one of those guys. So I was really excited to go up and talk to you again. And there's another secret ulterior motive that I have for this, which is people are always asking me, hey, will you review this motor or that motor? And number one, there's too many interesting motors out there for me to have time to look at them all. And apparently you do.
Even I don't at this point. My goodness, it's getting crazy.
And then the other thing is that you do such a damn good job testing them that I go, well, I mean, I could put it on a quad and fly it and go, oh, seems all right. But you're so rigorous. And so I would love to talk to you regularly. Hope maybe that'll happen, maybe it won't, but about just the latest motors, what's new every 2 months or something. We could do one of these and talk about this stuff. But I thought today that what we would do is I want to talk about T-Motor's line. Because T-Motor has some great motors, but number one, they name the motors, like the motors that I'm thinking of are F40, F60, and F80. I'll have to make some, by the way, I'll make some graphics, so like some PowerPoint slides, and I'll put them on screen when I edit this for air, so that all these terms we throw around, we'll end up with some kind of a table or something. But they've got those motors, but they don't actually give them the sizes. Like most people would say 2306, 2207. And then they've also got, I think they've split their line where there's like the F40 and the F40 Pro, and the F60 and the F60 Pro. And I thought a great way to, number one, just talk about T-Motor's motors. And for somebody who wanted to pick a motor, which one would they pick? And then number two, it feels like T-Motor is really just sort of branching in all possible directions, so that even if you weren't going to buy a T-Motor motor, you could get an insight into how to think about motors by dissecting T-Motor's line. So that's what I want to try to do in this interview. What do you think?
Yeah, great. Sounds good.
Okay. So where should we start? We should start, there's the F40, the F60, and the F80 are the ones that I can think of. Are those the three sort of major level tiers they've got?
Yeah, you've also got the F20 line, which is their micro motors, but that's kind of a different classification.
Yeah. So what are the differences between the F40, the F60, and the F80?
Right. Well, I kind of want to talk a little bit before we get into the exact differences about the philosophy that T-Motor is taking with this idea of using a name rather than a stator size to kind of identify their lines. And I actually kind of like the idea because what they're dealing with is classification and categorization, and how you choose to categorize motors may shift some over time. And personally, I wish we would spend more effort categorizing motors by weight rather than stator size, because in the end, what matters is how much power a motor produces for the weight that it costs you, not necessarily what the stator size is. What matters is what weight it is. So if you have a 2207 that's the same weight as a 2205,
Right.
I mean, really, you don't care about stator size, you care
Yeah,
about the weight per power
nobody
cost.
cares if the motor is 2 millimeters higher. It's not like we
Right.
don't have space to spare. It's the weight, and especially as we mentioned in our last interview, the weight at the ends of the arms, 2 or 3, 4 grams out at the end of the
Mhm.
arm matters a lot more than 4 grams at the center of the quad in terms
Right,
of.
right. And obviously how you're flying, that
Yeah,
relationship changes depending on how you're expecting it to handle, but and where in your throttle you're spending a lot of your time. But yeah, so I mean, I kind of like the idea of removing the categorization from purely the stator size,
Mhm.
which is T-Motor has done to a large extent. The F40 line started out as 2204 originally,
Mhm.
and has kind of shifted through 2205 and into now 2306.
Mhm.
So where it's kind of allowed them to shift and keep it in the same classification in terms of weight and kind of where it fits into the scheme of their power ratings,
Right.
but not be tied to a particular stator size. So it's an interesting approach, and I think that a lot of people have found it confusing to a certain extent, but at the same time, I understand where they're coming from in terms of why they made that decision.
Yeah, and I've seen this coming up probably because I've been reading your website. So I'm like, yeah, I've been hearing that. Oh, I've probably been hearing it from you. You focus a lot on motor weight in your reviews, in your tests, and as you say, if you've got a 2306 or a 2407 motor, the size is it's down at 29 grams, then you're kind of getting something for nothing. you
Right.
know. So, and that's one reason we've seen, I mean, the motor manufacturers are on board with that. That's why we've seen the shift to naked bottom motors
Hmm.
because they're saving. What are they saving? What's the difference? Is it 2 grams?
Yeah, a gram and a half, I'd say
Yeah.
probably.
Which doesn't sound like much, but when your goal is to when your goal is to get a 34-gram motor down to 29 grams, a
Right.
gram and a half is a big
Well,
chunk.
and if you think about it too, even if you keep the weight the same of the motor, what it's doing is it's removing weight that's dead weight, that's
Right.
just not doing anything, and allowing you to put that weight into parts of the motor that are actually productive, that
Right.
actually produce power. So, I mean, the ideal would be a motor that's 100% of the weight is going to producing power.
Right.
Obviously, you can't do that. There has to
Right.
be structural elements.
Right.
For instance, moving the weight from the bottom of the motor, reducing the weight in the mount, and then moving that weight into the flux ring
Hmm.
is a productive change. So that flux ring allows it to basically curve more of the magnetic field lines back towards the
Which
stator.
part of the motor is the flux ring?
The flux ring is the steel ring that contains the magnets.
Okay.
So
Is that
that's
is that the bell?
it's part of the bell. It's the
I
it's the part of the bell that's made out of steel instead of aluminum.
I got you.
And it has to be made out of steel in order to function properly,
Because it
because
has to be
that's
ferromagnetic.
exactly, it has to respond to magnetic field lines. So by thickening that flux ring, you're actually allowing or preventing more of those magnetic lines from escaping the bell and
Mhm.
folding them back in towards the stator, where they actually produce more
You're
torque.
you're making me think right now of the ZMX Phoenix motors, or Phoenix.
Exactly.
People will point out they're
Phoenix, yes.
pronounced Phoenix. I'm a very literal person, but yeah, Phoenix motors, where they've got the what is it called? What's the term for it? There's a name.
Well, there's not really a term at this point. I mean, it's modeled after a Hallback array, but
Hallback. That's
it's
it.
not a Hallback array. It's basically simulating the effect of a Hallback array by varying the width of the flux ring.
And what
So,
the manifestation of that is that if how if you take your motor and you put like a screw next to it, it'll stick
yeah,
to it with magnets. Well, if you got one of these Phoenix motors from ZMX, you could put something up against it. It doesn't really stick, and
yeah,
the
barely sticks.
magnets are not weaker. It's just that
Well,
more of the magnetic force is sort of staying inside the.
mhm.
Is that
I mean,
right?
it is yes, that is true. But what it's done is it's allowed him in this particular instance. Again, we're getting off topic here, but this
No, off topic.
why
We'll
not?
get.
So what it's done is it's allowed him to basically reduce weight further by using thinner magnets and
So
retaining the same
he's
magnetic
using
field strength.
but because he's keeping more of the magnetic field strength in the motor versus out of the motor where it's wasted, he uses thinner magnets, gets a lighter motor, but with the same magnetic field strength, and that magnetic field strength directly pertains to
Correct.
power.
So now in this particular instance, it does seem to have come at a cost in that they're not quite as efficient as some of the other motors. So using lighter magnets and then increasing the field strength through other means seems to, obviously my sample size isn't large enough to make a definitive statement in this, but in this instance, these motors are not, especially in that top end of the throttle, they are a little bit more current hungry than some of the other equivalent motors in terms of the power production. But I mean, when you're dealing with that much reduction in weight, you're going to see greater unloading. So it seems to basically balance out, or even maybe introduce a slight advantage over heavier motors that may be technically more efficient, but are not unloading as much or as quickly in the air. So
I flew them on my Talon. And my Carrera Talon build was not ultra light. I can't remember the weight, but I think it was, oh, I won't guess, but it's not ultra light like a floss build. But I didn't find them to be ultra amp hungry. I found the 2207 can be a pretty beastly motor depending on how it's designed, but I found them to be pretty reasonable. So
yeah, and one of the things that I've noticed again with the ZMX, and I've seen it with this particular Phoenix motor, but again, I've seen it in other motors as well. Heat is a major issue, especially in static load tests, in terms of efficiency. You can end up with significant loss of power production as heat rises in the stators. So you'll see, for instance, it'll hit a nice big spike at the beginning, and then motors that don't have as good heat dissipation will end up, you'll see a slant as the thrust kind of tapers off as the heat saturates the stators and they lose efficiency. So I think some of that is what's happening with the ZMX Finex motors in terms of they're losing efficiency on the stand due to heat buildup because they did get very hot during the test sequence.
Yeah. But they didn't get super hot. Then again, I was only, when I looked at my throttle position as I was racing, quote unquote racing, not racer, but my throttle position was typically around 30, 35%. Even on the straights, I wasn't hitting full throttle because I knew if I did, I would just overrun the next turn and
right, exactly, manage it.
So well, it was really only during sharp turns that I was even hitting 50, 60% throttle. So maybe that has a lot to do with why the motor seemed relatively efficient.
Well, and it also, I mean, it comes back to understanding what you're looking at when you're looking at static test results. I mean, there are differences between static tests and in-flight data. Now, that doesn't mean static results aren't relevant.
I agree.
It just means that you have to understand how to read what you're looking at and how to translate it into forms that are useful to you as far as how it's going to work in flight. So, kind of pulling that back to the T-motor line, I mean, that's a good kind of a good transition back into this line because they have all of these different, derivatives because they do produce different results in flight.
So let's go back to that where we started. So the F40, F60, and F80, how would you divide them up? Along what axis or what differentiates them from each other? Then?
Sure. So, I mean, they do increase in stator size as you go up in, up in
the numbers.
In the numbers.
So, what are the stator sizes? But first of all, by the way, is the F43 and the F40 Pro, are they the same stator size?
They are at this point, yes.
And likewise, the 60 and the 80.
Yes.
Okay, so the F40 then is 2306.
Now, the F42, if I'm remembering properly, was 2305.
Right.
And it was only the Pro that jumped to 2306. But now with the F43 and the 3 line of motors, the F3s, they have matched now stator sizes between the Pro and the non-Pro line.
And then the F60, I think, is 2207. Is that right?
Correct.
Okay.
Yes.
2207-ish. And that's true also. Is there an F3 version of the F60?
Yes.
Yeah, F60. So there's an F63 and an F60 Pro.
Right. And then there's the F80 Pro. Actually, it's just the F80. They haven't released a derivative or a Pro line of the F80. Now, the F80 is very, very close to the Pro line already. The only difference being that it's not using the same windings as the Pro motors. The bell design and even the anodizing and everything is essentially identical between the F80 and the F60 Pro. It's just a larger stator and is not using
How big is the stator on that one?
It's 2308.
2308. So that's a pretty big motor. I know a guy who
flies a honking motor
on 5S. They do pretty
Mhm.
well on 5S. I'm not even sure what is that something people are running on typical 5-inch, 4S props, or is that really for?
I think it's mostly used either on larger props or
Yeah,
on higher voltage, just because
yeah,
the weight. I mean, it's like 43 grams, so
yeah.
that's
You're
that's
going to
yeah,
build like a 7-inch racer, which some people are doing now,
yeah.
apparently.
Well, and I don't know if it's racers, but they're building 7-inch,
Yes. Yes.
freestyle slash mid range kind of flyers.
I will say this about this guy had a 5S F80. It was it a chameleon? I'm not 100% sure. I think it was an alien. He built a, oh yeah, no, it was a butter quad. He built a 6-inch butter
Mhm.
quad with F80 motors. And I flew, first of all, it was fast as shit. We didn't have a radar gun, but I guarantee it broke 110 miles an hour. Like I just guarantee. Because normally when you do speed tests, right? My experience is when you do speed tests, the quad goes by and you're like, oh yeah, that was pretty fast. And it was like 100 miles, 100 miles an hour with a little tiny quad doesn't look as fast as it feels. But this thing, when it went by, you were just like, it was almost. And
Well,
then
that's the F80s are what Flight Test is using on their follow quad, the 6-incher.
oh,
They clocked that, I think, at 87 miles an hour on the 2200 kV
and that was on 4S, presumably.
F80s. Yeah, on
Yeah.
4S. It was like a 20, it was a huge honking battery, like a 3000
Yeah.
milliamp hour or something.
But here's the thing: when I flew this quad, you expect certain things out of a 6-inch. Number one, you don't expect fantastic throttle response out of the props. You expect those props to be just a little bit laggy,
Mhm.
grunty in the low end, but lacking in top end a little bit. And then you also expect it to be. It was so, but it wasn't any of that. It wasn't any of that.
Right.
It was so. In fact, it was so locked in on the corners. I couldn't freaking believe it. It was like you're getting all the thrust and grip of a 6-inch prop, but with none of the sort of downside. I guess the
That
higher voltage
tendencies,
and the
right.
big. This
Yeah,
thing
so
flew
the larger
unbelievable.
stator basically puts the 6-inch prop lower in the torque loading for the motor, so it's changing speeds more like maybe a mid-range heavier 5-inch prop. So something like the
Yeah,
old
exactly.
5x4 5 HBNs, something like that.
It just
Comparable,
felt like a ridiculously powerful 5-inch quad. It
right?
really say. So then we've got the stator sizes, the 2306 and 2207. We could just focus then on the F40 and the F60 then, since the F80 is kind of out of the most
Yeah,
people.
it's in its own thing. Oh, it is worth noting while we're talking about the F80s. I'm
Yeah,
pretty sure that's what they used to break that 10s speed record if with
I believe
DRL.
I
It was
believe
the
it.
2500 kVs on those APC speed props.
I just can't even
So
imagine 2500 kV on 10s.
yeah,
Just
it
just
makes you wonder what they could have done if they used better ESCs. Maybe not.
So then what kind of differences are there in the construction of these motors above and beyond? You want to run off any more stats first of all? Those so we got the size. What about the weight? Let's just get the stats
Yeah,
down.
so
We'll
the
put the
the
table
weights are
up.
pretty consistent. The F3 line is a little bit lighter, just tiny, like 1 gram lighter than the pros.
Okay.
Probably mostly due to the magnet weight in a little bit in the bell design. Um, but and that is the previous Pro line, not the Pro twos. The
Hmm.
Pro twos obviously are a step lighter because they went open bottom and they completely redesigned the whole bell system.
Yeah.
So so we've got there's 3 motors that we're talking about here. We've got the original F Pros, we've got the F3s, and then now the F Pro twos.
Hmm.
So the F Pro 2 being the absolute lightest,
Hmm.
and then kind of working down. Um, the F43 being kind of middleweight. So for the 60 series, you're looking at like 34 grams, 30, a little over 33 grams for the, or a little under 34 grams, a little just in the 33s for the F60. The the F uh, the F63 was like 34-ish and
Hmm.
some change, and then the F60 Pro, the original, was like 35.
And I'm going to hold you to all these numbers that you're just pulling out of your head with no prep. If any of them are wrong, we'll get crucified in the comments and have it coming.
Yeah,
So
right.
we'll check that. But and that so those are all in roughly the 33 to 35 gram weight.
Right, and it's a 2207 size. So, and then obviously well, 22.7 ish.
Yeah.
I actually pulled apart the F60 Pro II, and it's actually got 3 extra plates, so it's actually like 22.7.3,
No.
so it's a little bit taller
Yeah.
than the other, which, given the fact that they even still kept the weight down, is pretty impressive.
And then the F40s are what are they approximately? Weight wise, they're a little lighter.
Yes, so the F40s were the original Pro was like 32 grams,
Hmm.
and some change. The F43 was, I think, right about the same. Actually, there wasn't as much difference between the F40s as there was the F60s, which makes sense because they're, the larger you go, the more the difference is going to be. And
Yeah.
then the new one is what surprised me. The F40 Pro II is like 29 grams,
Yeah.
that's a significant weight
Yeah.
reduction.
Oh yeah. Yeah. When you said 33 grams for the F43, I thought. And by the way, in case anybody's not
The
clear,
F63.
it's the F40-3, not the F43.
Oh yeah, F40. Yeah, right. Okay.
I thought, those are all in roughly the same category, the F40 and the F60, right until you get to the new ones, that's only like 29 grams. That's a
Right.
pretty significant weight reduction. So then what differentiates in terms of construction or design philosophy or whatever, what differentiates these motors? And most fundamentally, what is the optimal sort of application or the optimal, who would pick what each of these motors? That I think is the real meat of this interview for viewers.
Yeah. So the obviously the Pro motors are focused on making as much power as they can without making any sacrifices. Like, they don't care about efficiency, they don't care about anything. They don't really, they just want to produce power, and that's it. So obviously the first one, they weren't caring so much about weight savings, and obviously the Pro 2 has shifted that to take the performance and weight savings together. I haven't actually run them yet. They're sitting on my bench waiting for me to get time. The holidays have been crazy this year, so my bench is lonely.
But your family is happy.
That's true. That's true. Which is always a good thing.
Mhm.
So the F40-3, as you say, not F43, F40-3,
We'll keep saying F40 at once.
is kind of it's a more conservative approach to motor design.
Mhm.
They've scaled back the magnetic strength. They've increased the air gap just a tiny bit. They're just overall a more conservative motor. They're not using the silver windings, which actually I had an opportunity to test. I was involved in the prototype testing for the
Mhm.
hype train motors,
Mhm.
from Rotor Riot, and I actually got to test back to back identical motors with only the windings different and with only
That's
magnets
cool.
different.
Because when I don't give the result yet, because I'll tell you when I reviewed the hype train motors and I talked about the silver winding, as I said, well, I don't know how much of a difference that really
Hmm.
makes. And somebody came to the comment section with some math that said at the frequencies we're using. So hang on, back up a second. There's a thing called skin effect,
Hmm.
which
Right.
means that you have AC current moving in a wire. The current actually doesn't move through the center of the wire as much as it propagates towards the
Across the
edges. So
surface. Right.
if you wanted to, theoretically, you could coat the wire with a very low resistance metal, and then you would get much better current flow and less heat buildup, even though the center of the wire was maybe a higher resistance metal. And
Right.
that's the theory behind the silver winding, the
Hmm.
silver plating. But people said, oh, the skin of the silver plating is only 0.7 microns thick, and the skin effect is, and basically said that it couldn't make a difference. It was all cosmetic. And now you're going to tell us whether that's true.
Yeah, so I actually had a chance. They sent me 4 different motors to test with. There were 2 different magnet strengths and 2 different windings. One with silver, one with copper, just straight copper, and then 2 different magnet strengths. And it was actually really interesting. I took one prop and ran the motors back to back immediately in sequence
Mhm.
to minimize the number of variables that are different. Because environmental variables actually account for more than you might
Yeah,
think.
yeah,
In terms
yeah.
of just small changes in temperature and pressure can account for more than you would think in terms of difference, maybe 15, 20 grams. of thrust and maybe half an amp or even a full amp of current. So that's pretty significant. So in order to minimize that, I ran those immediately back to back to back, right in sequence, right after each other on the same prop. And I actually was able to show a fairly significant difference between the magnet types and between the windings. I mean, fairly significant is relative. Obviously, it's
like what percent?
Yeah, like probably like 1%. I don't remember the exact number, but it was significant enough that it was worth it, in my opinion, for the silver windings. It increased the efficiency by just a tiny bit, especially not as much in the lower throttles, but as you get into the higher throttle ranges, there was a noticeable gap between the two, and it was cool because I had two samples. I had two silver windings,
right,
and I was able to cross combine those to get a nice crosstab to show where the significance lies.
So it sounds like it's a very small difference, but definitely a difference.
Right. Yeah. I mean, if you're looking for that last percentage of thrust, I want to say it was about 30 grams difference.
I mean, you say 1%, it doesn't sound like much, but you say 30 grams, you go, well, that's something.
Well, actually, I think it was, now that I'm thinking about it, it's probably closer to 2% because it was about 1450 grams of thrust, I want to say, and it was just under 30 grams. So like,
yeah.
I can go back and look later,
sure,
but that's within a reasonable approximation.
When you think of those 20 grams of thrust, it's worth keeping in mind. Folks try to save weight. People are trying to build the lightest quad possible, and what would you do to shave 20 grams off your quad?
People right. And that's 20 times 4, so you're dealing with.
That's a good point. That's a good point. 20 times 4, 80 grams. Now it doesn't sound so trivial,
right.
But even 20 grams. I mean, the thing is that what I like to say about weight saving is that you could do the obvious things to save weight. And then once you've done all the obvious things, everything else is hugely incremental.
Right.
So you're going to save 2 grams here and 4 grams there, and none of it is worth anything. But when you do all of it,
add it all up together.
Yeah, it adds up to a lot. It's like the guys trying to get a race car lightened up, and they just pull everything out. They pull the seats out. They pull the air conditioner out. They pull the liner out. Everything is, a few ounces or a few pounds here, but by the time you're done, it adds up to a lot. So that 20 or 30 grams or 80 grams, that
adds up. And, obviously, again, it goes back to there are differences between what I'm seeing on the bench and what you're seeing in the air. 20 grams on the bench doesn't necessarily equate to 20 grams in the air. But what it means is that there is a measurable difference. Yeah. And that is valid regardless of whether it's a direct one-to-one analysis or not. Right. It's still going to require someone to go and fly it to figure out how that.
Here's the thing about that though, and now we're just shooting a bull, but I've been doing this battery. I got this battery tester. Actually, I just received they sent me the battery tester, the sort of the core unit. I have that. I'm going to do an unboxing video soon. But I'm waiting on the 2 kilowatt load, the amplified load that they have to special order because it costs $3,000 and nobody buys them except weirdos like me.
You.
And some people have said, what's the point to all of this? Number one, they've argued bench testing doesn't reflect real world results. And I know you obviously don't agree with that, or rather bench testing doesn't directly reflect real world results. But if you understand the parameters of the bench test, then you can extrapolate real world conclusions. And the flip side is that real world results are so uncontrolled that in order to get meaningful data, you would have to do thousands and thousands of tests.
Yep.
Whereas if you can come, I think there's advantages to both.
Absolutely. And I mean, I think anytime there's a disparity between bench results and the real world, like outcomes that people are experiencing, it doesn't necessarily mean that those results are invalid on either side. What it means is that our understanding of the connection between the two is incomplete.
Exactly.
So like I have spent hours talking with people like Jason Bauslaw, who is very critical, and I appreciate that we can come together and we can kind of go back and forth. Well, this is what I'm seeing here. And he said, well, this is what I'm seeing in the air. And we've mutually come to some very interesting conclusions about the relationship between these things. And that's a really fascinating conversation to have. But it's the reason why I do all this, and the reason why I love what I'm doing, is because it helps us better understand the world we live in. I mean, that's what drives me as an academic, as as an individual. And, you know, I'm not necessarily, I don't know how you want to call it. I think of myself as a scientist, even though
I
I'm
feel,
not
I'm a firm
necessarily.
believer. I'm a firm believer that there's a common myth about scientists, which is that scientists all work for big corporations or universities and wear lab coats. And I'm a firm, and I really, this is like one of my core philosophies, is that everyone should be a scientist
Absolutely. I
from
mean,
the minute you're 3 years old.
yeah,
And actually, I think kids are natural scientists because what does a
absolutely,
scientist do?
man.
They experiments, they look at the results, they learn about the world. Kids, that's
Science
all.
is a way of thinking more than it is anything
Yeah.
else. I mean,
So
it,
everyone can be a scientist. Everyone should think like a scientist. Not
absolutely.
not not 100% of the time. Maybe when you're, when it's nighttime and you're with your wife, don't think like a scientist. But
What?
everyone should think like a scientist at least some of the time. Yeah. I think you're a scientist. I call myself a scientist, an amateur scientist, but
Sure.
yeah.
But I mean, when you start getting the level of the depth of the data that's available, and start seeing things, you know, it's very interesting. You know, I work at a university. I'm sitting in a recording room at the university where I work, and I've had some very interesting conversations with people from our science departments here, you know, from our schools of engineering and physics, and they're actually really interested in the results of what I'm working on, which is pretty cool to have that kind of affirmation
Yeah.
of as an amateur, that people who do
Well, and
this
here's the
for a
thing. Here's
living
the
are
thing.
interested.
Eventually, you're an expert. If you think back to the scientists, who are the original scientists? Guys like Francis Bacon, guys like Isaac Newton. They weren't employed by anyone to do these things.
Right.
They
At
were
least not at
just,
first.
at least not right. They were just guys who had an analytical mind who sat around under an apple tree thinking about why. I know that's a myth, but they were just people who had a lot of spare time on their hands because they were rich and they spent time thinking about these things. And there's no reason we can't emulate those people. And yeah, for sure.
Except for the rich part. You
Well,
know?
the great thing is we don't have to be aristocrats anymore. We just have
Right.
to have a
We have
YouTube
the
channel
internet.
and a basement. But let's go back because you talked about the F40, the 3 line, the F3 line versus the Pro line. You said the 3 line is a little bit more conservative, so it has things like weaker magnets and
Mhm,
more air gap. The air gap being the distance between the stator and the magnet.
mhm.
If you look inside your motor, you'll see that modern motors they've really reduced the air gap, and of course
Some of
magnetic.
them are just insane.
Yeah, how tight they are, really
Yeah,
ridiculous the
it's
tolerances.
it's crazy.
And of course, anyone who's played with magnets knows that magnetic field strength drops off over distance. In fact, I'm pretty sure it's inverse square.
Yep.
If it knows
It's
what
the
that
inverse
is,
square law.
which means basically the further your magnets are from the stator, the more energy you're sort of losing in
Mhm.
that distance, and the closer they are, the more thrust and
Right.
power you get out of the
So
motor.
I actually had some long conversations. I've been testing motors for T-Motor for a long time. They were one of the first people to approach me, and I've had a lot of feedback on their motor design, and been had conversations with their engineers, and you know, talking with them about this motor. In particular, the slight increase in air gap was intentional, not from a necessarily performance perspective, but from a durability perspective.
But you were going to say that.
And this is one of the
Yeah.
things that you've noticed about motors like the Emax motors or some of these other crazy motors that have air gaps that are just infinitesimally small.
Right.
So basically, if that motor bell gets out of alignment at all, if it takes any sort of impact that will shift it
Hmm.
a tiny bit, that magnet runs into the stator and ends up shattering. So, you know, their interest in increasing that air gap just a tiny bit was to give it a little bit more space so that it wasn't, you know, running into the stator so easily during impacts,
Hmm.
and kind of make that just a tiny bit more durable.
Frankly, metal is just a little bit flexy. All metal is just a little bit flexible. You could imagine a scenario where the spinning motor takes a hit and actually is not permanently deformed,
Mhm.
but because it's spinning at 30,000 RPMs. When it deflects just a tiny bit, now
Yep.
the stator is scraped up, the magnet is exploded. Whereas if it had had just a little bigger air gap, it actually would have been completely fine
Mhm.
after the impact.
Yep,
Yeah.
exactly. So, I mean, I understand that approach, and I think that was smart. So, um, the performance, you can definitely see it in the performance. The response times are not quite as snappy. The top end isn't quite there. The low end is very similar, but when you start getting above about 50-60% throttle, you can see that kind of torque flattening out as it loses its ability to just keep increasing the RPMs of the prop. So what they've done is they've kind of increased kV to compensate for that. So you see like the F60 3-3 has a 2750 kV version, which tested a little lower than that on the bench, but they're basically it has similar power to maybe the 2450 kV Pro line, but they've kind of increased the durability factor a little bit, and it changes we had the same conversation back on with our last video where it changes the throttle curve. And I know some pilots, talking with Damian Gans and some of these other freestyle pilots prefer a throttle curve that's very specific, and he can get that throttle curve out of the F40 threes. It's just a little bit different. It has similar power output, but it's the way it responds to the throttle. The response of it is a little bit different, especially if you're using lighter weight props. That those differences become more and more obvious. So, kind of just an interesting approach there. So, you talked about originally. You were asking, well, why would I choose one over the other? And I think the most important thing a pilot needs to ask themselves right off the bat is, or not even ask themselves, but figure out. The first thing you need to figure out as a pilot is, what am I looking for? How do I like to fly?
Right.
Like identifying your own style, identifying your own constraints.
Let's pin that down a little bit, because let's identify some axes. A person could, because you go, well, I kind of like to do barrel rolls. No, well, we mean, so one thing that came to my mind, hang on a second. Let me make sure I muted my phone. It's buzzing at me. We'll cut this part out. So one thing that came to my mind when you're talking about the difference between the Pro line and the F3 line is the efficiency. That the Pro line is going to try to make thrust at all costs, damn your batteries, and the F3 line is going to be just a little more conservative. So certainly one thing a person could ask themselves is, how much do I care about efficiency versus performance?
And that's a really, really interesting discussion. And I don't know if you've been on my site at all. I mean,
we should plug your site, by the way. Of course, it'll be in the video description, but your site is miniquadtestbench.com, where you do motor and ESC testing. Really,
I haven't done a couple other guys in a long time, though. I need to get back on that bandwagon.
But frankly, ever since BL Heli S, I've kind of thought the ESC testing is not as interesting as it used to be.
Yeah, well, and that's one of the reasons why I have scaled back, is they're all so similar. I mean, I've done some initial testing of the BL Heli 32 just to kind of benchmark it against the others, but I haven't published any of that yet, just because ESC testing is insanely time consuming, and there's so many motors on the bench. I'm overwhelmed right now.
I think the biggest difference with ESCs is durability. And reliability.
And you're not going to tell that from a bench test. I mean, like I said, it's interesting to see the response, particularly to compare, like, categorically, to compare BL Heli 32 versus the BL Heli S versus the BL Heli, the old school BL Heli F390s versus the KISS. And in particular, I'm interested in how the KISS current regulators, the current limiter, thank you, is impacts the response time of those ESCs, and it's very clear in the data, which is really interesting. But that kind of categorical testing is interesting, but getting into the details of, like, testing all the different brands of ESCs is almost irrelevant at this point.
Frankly, this would be an interesting test. Maybe Snake FPV will do it. He's big on doing blind tests nowadays. It'll be an interesting test to take, like, a Racer Star and a top ESC like a SpeedX, or an Acon, and put those on an otherwise identical quad and have a pilot fly them. The only difference would be that if one of them lights on fire, it's definitely the Racer Star. If you get a Racer Star, I think that their defect rate is a little high, but it probably means that instead of 1 in 10,000 lighting on fire, maybe 1 in 1,000 lights on fire, which is still pretty low.
But given the volume of those out there, that's high enough to be an issue.
I don't recommend Racer Star because I think they're a little too likely to light on fire. I just heard too many stories of people who bought a Wizard and the ESCs popped for no reason.
Right.
But I'll bet when they're not lighting on fire, you couldn't tell the difference.
I agree. You know, and it's been interesting because I've done some multi-axis testing. You know, I recently did a whole bunch of tests to compare like back to back with things like timing and startup power and some of those settings of questions of like where can we actually start to see changes in you know, prop acceleration and that kind of stuff. And it was, you know, where the current spikes hit and all of that stuff. And I may publish an article on this at some point.
That'd be great.
But I did the testing because I was having a discussion with someone on our C groups who was questioning, you know, particularly that acceleration curve and the current spikes that happen when you're going from idle to sudden changes in throttle. Basically, there's a massive current spike, 200 amps.
At the end of a flipper roll, when the motor that is idle now has to spin to basically instantaneously.
Instantly, right.
Right.
So, but yeah, so I did some really interesting like four-way cross-tab testing of the multiple variables there between timing and startup power, and got some really interesting results. So I probably will, when I get a chance, write that up and include some graphs. And
well, another video I'd love to do maybe sometime in the future is I owe everybody a Bill Helly 32 video. I haven't done it yet, so maybe we'll talk about that in a future video. I'm sure you have a lot to say about that. Go ahead.
Where were we?
Yeah. So, well, we were talking about axes along which a pilot could categorize themselves to help them pick a motor. And one of them I said was efficiency, whether you want a little bit more.
And so I got distracted, but I was saying I recently added 2 charts to the Data Explorer page that I have been spending hours just filtering through the results, looking and comparing. So basically it allows you to take either a throttle percent or a thrust value and compare efficiency at exact points.
Oh, so you can say at half throttle how efficient, because motors is a very interesting topic. We always think about motors at 100% throttle. We'll say it makes 1,600 grams of thrust at 3.9 grams per watt or whatever, grams per yeah, you know what I mean. But many people aren't running it at full throttle all the time.
And that's not really a valid comparison. You know, it's you have to look at multiple different ways of comparing the two. So looking at exactly the same thrust point is a much more valid comparison of direct.
2 motors are both making 1,400 grams of thrust. One of them is 100% throttle and is maxed out. The other one is at 80% throttle. But if they're both making 1,400 grams of thrust, that's what you care about as the pilot.
Right.
And maybe you know.
So what's interesting is that ends up being much, much closer than you would expect.
What do you mean?
The difference in efficiency between motors is very, very small when you start comparing exact thrust values, like smaller than I anticipated. The deviation is actually significantly lower than I expected. So like you might see 2.7 on the minimum and like 3.1 is the maximum.
So if you pick, what you're saying is you pick a thrust value, like 1,500 grams of thrust. That's probably a little high, but
yeah. So I usually compare. There's a couple of points that I like to compare because they're kind of where we are flying. Okay. So I like to look at 800 grams because that's kind of a decent fast forward cruise. Like you're going pretty fast, maybe 50 miles an hour, 40 miles an hour. 800 grams of thrust is a pretty good, you know, RPM per point to kind of compare those. I also like to look at like kind of really aggressive, so somewhere in the 1,200 gram range, because that's low enough that you're still going to catch a big range of motors, but high enough that that's like you're really pushing it at 1,200. That's like pretty high in terms of speed. And then I also like to look around 500 grams, 300 to 500 grams, because that's kind of the lower end of cruising
like hover
speed.
Thrust, roughly.
It's more than hover. It's a good forward speed kind of.
Sorry, because there's 4 motors. Duh.
Right. So you're looking at pretty decent, maybe 30 miles an hour forward speed, kind of just cruising.
So I think what you're saying is that when we look at motors, if you're a nerd like us, and most people don't, but if you look at motor efficiency and you see a fairly wide range of efficiency, some of them might be up at like 3.4 grams per watt, some of them might be down around 2.8, 2.7, which I would call pretty efficient. But what you seem to be saying is that the perception there is because you're not taking into account the thrust the motor is making. That
Right.
a motor making 800 grams of thrust actually, regardless of the motor, will tend to fall in a much narrower range of efficiency values. You're
Right.
essentially saying all motors are roughly equally efficient?
No, it's not equally efficient, but I think that a lot of the differences that people feel is
Mhm.
because they're using the motors differently, not necessarily that the motors inherently are at a given point. And that's, that's, to me, that's as much of worth taking into account is looking at a particular particular thrust value. It just means that there's more to the picture than we necessarily understood in the beginning. We have to kind of look at it as a more complex problem.
But it's a given that, I mean, I think it's true that an F40 Pro is going to hurt your batteries more than an F43. That's inherent to the design.
Absolutely.
Yeah.
And it was an interesting, I watched a video that Snake did, I don't know, a month ago, 2 months ago, comparing the steel motors versus the hype trains.
Yeah. Mhm.
And it was interesting because he made some comments that I thought were really interesting, particularly about his throttle timer, coming down, different with the steel versus the,
So just for perspective, in case anybody didn't see the video, he flies with a throttle timer. And what that means is that he has a timer, like a 2-minute timer that tells him when to land. But the timer is accelerated or slowed down based on how high or low his throttle position is, right? And it actually does a pretty decent job of estimating how many
right,
milliamp.
but it has to be tuned for a particular motor combination.
Exactly.
And that was an interesting thing that I got out of his discussion there, was that he noticed there was a variance. But then he mentioned that he felt like the two motors were equal in power, but his throttle timer kind of exposed the fact that it wasn't, because obviously if he was coming back with more time on his timer in with the hype trains, that means he was lower in the throttle for part of it.
Couldn't that oh, I see. Yeah, because I was going to say, couldn't that just mean the motor was more efficient? But no, because the throttle
No,
timer doesn't know anything about that.
exactly. All it knows is that it's taking less throttle to produce the same amount of power.
Exactly. Very interesting.
So, and the other
So
thing that he mentioned,
are you saying that you disagree with his result? I mean, I'm not trying to.
well, he actually posted a second video later on and clarified some of that and came to some of those conclusions after having stopped and thought about it for a while. So yes, I disagree with his initial results on several fronts, but I think he came around to it after spending some more time flying with them and thinking it through. He ended up coming to, I think, a valid conclusion. But the other thing that was interesting is that he made a comment about noticing the pitch difference in not
sound.
audible pitch difference, which is very interesting as well, because higher pitch means higher RPMs, which means higher speed. So he said he was flying the same between the two videos, but if he was hearing higher pitch on one than the other, that means he was using more throttle on one than the other, because it was getting, or not using more throttle, using more speed. Let me put it that way, because RPMs equals more speed. So he was actually flying faster on the one that sounded higher pitched, and that's just physics. I mean, that's
sure. Same.
If all other variables are the same, the higher pitch one is going to be producing higher RPMs, which means more forward speed. So, just some really interesting quirks there. But I think bringing back to the point, my point in all of this is that even with the differences, his flying style was in the terms of what he was looking for in his flying style, those two motors didn't make much difference for him because of how he flies.
Yeah.
So going back to our initial point of
saying what you're getting at.
Saying you have to understand what's important to you. You have to understand what you're looking for in terms of that style of flying. So you were saying like the spectrum, and this was going back to efficiency being one of those things, but efficiency may not impact you the way you think it will. Which was kind of where I was going with all of this.
I'll go back to the Phoenix motors, and this really ties in with what you're saying. Those Phoenix motors, if I was a racer who was constantly at 85, I asked the question, how often are you really at 100% throttle? And guys I know who are serious racers were like, every straight. What are you talking about?
Right.
And I'm like, oh, I'm not. I'm not.
I'm not that guy.
For me, when I'm quote unquote racing, I'm trying to get smooth lines, and if I go too fast, I crash. So I was running those motors at 35 to 50% throttle, and like you're saying, I might not notice much of a difference between those Phoenix motors and maybe a 2206, or at that point in the throttle curve, there's not that much difference until you really start pushing them. And
Right.
likewise for Snake, the way he was flying and what he was asking the motors to do, maybe there wasn't that much difference.
Exactly. So,
So
I think there's a couple of fronts where you can compare things that really are going to be the critical factors. I honestly don't think efficiency should really play much into your motor choice
really,
as much as other options, unless you're
like
racing. I
what,
mean,
like
obviously, I'm speaking more from a freestyle perspective. Obviously,
well,
racers.
and even racers who are not top racers, many racers out there are just guys like you and me who build one quad with their spare beer money, and
Right.
they don't have unlimited resources. So I mean, even if you don't freestyle, it's still, you're maybe not going to be buying the absolute cutting edge, damn everything else.
Right. And I mean, efficiency plays a role in that last percent where you're nailing the throttle just pretty much constantly. Like that's when you really need to start thinking about, okay, how am I going to fit 2 minutes and 30 seconds or whatever, two
Exactly.
minutes into this race and optimize it. And that's where you really have to start looking at that efficiency perspective. But for 90% of the pilots out there, they're not in that category. They're
So,
they're
so
not.
then so then going back to the question of the Pro versus, and we're going to also ask the F40 versus the F60, but hang on,
Mhm.
we're not quite there. Going back to the question of the Pro versus the F3 line, what would make somebody pick?
Right.
Uh,
So, in
yeah,
my opinion, there's kind of some critical points that you need to ask yourself. Number one, are you looking for snappy, responsive flying, or
hmm
are you more about smooth lines and like careful, that careful kind of smooth flowing feel, or are you looking for flowing during parts of it and snappy during others? So, the snappiness is going to be where you're looking for torque.
hmm
That's where you want it's a combination of kV and torque that gets you that snap. So
hmm
understanding whether you're looking for snap, whether you're looking for smooth, whether you're looking for proximity where you're doing a lot of close flying and throttle management, or
hmm
whether you're looking for big open spaces where you want that
want
big
the raw
response
speed.
that's going to
Yeah.
launch you, and get you some distance very quickly. So understanding, number one, where you're flying, number two, what you're expecting your quad to do, how you're expecting it to handle. All of that plays into choices as far as choosing a motor. And obviously, choosing a motor is only one component. That's going to play into your
Sure.
choice of frame, your choice of
Yeah.
battery. All of that stuff is going to play in as you're building a quad. So that's why I always encourage pilots who are asking me questions about, well, what motors should I run, is the first thing you need to worry about before you worry about a motor is, how do I want to fly?
Right.
How do I express myself as a pilot, and what do I look for? Because that's the first point where you need to start. I mean, to a certain extent, you can find a rig that and kind of work that into your
Mhm.
style and let that inform
Yeah.
your style. But
Yeah.
it still is it's kind of a symbiosis, as far as understanding those relationships and letting them feed off each other.
hmm
So,
So
going
who's
back to the F43 versus the F40 Pro, the Pro is going to give you that torque. It's going to give you that instant response. It's going to give you that snap, where the F43 is going to give you, the smoother response, the kind of the the higher resolution throttle control, where
hmm
you're not dealing with big jumps in throttle, you're dealing with smaller shifts in throttle, which is what a
right.
lot of freestyle pilots like. And so, like, the interesting thing is, like, it's kind of all on a spectrum. So you
Sure.
balance the torque production versus the kV. So, like, Damien loves those F43s, 2750 kVs, and he uses lightweight props.
hmm
So when you're dealing with lightweight props on a fairly large stator size on a weaker magnet motor with a high kV, you kind of are sitting in this interesting intersection
hmm
where you get that kind of smoothness and the higher resolution,
hmm
as well as some of the snappy
because you're
character
running such
traits.
light. Like just before the interview, I just did a test flight, very first one on this quad. This is a
Mhm,
Copus, but
mhm.
instead of the T motor airs, I have put
The
EFAW
EFOS. Mhm.
2407s on it. And I run it. I ran it on, these are Dow Cyclone 5040 T5040C props, and they're relatively light props, not the
Mhm.
lightest, but
Yeah.
they're not heavy. And I wondered if they might be underpropping the motor. But I think what you're saying, and I'm kind of coming to agree, that there can be some real advantages to underpropping a motor you're not so much wasting. I mean, in a sense, you're wasting the sort of raw thrust that you could get out of it if you put a heavier prop. But on the other hand, the response and the smoothness goes way up.
Yeah, I just recently had an interesting experience. Jason's been hounding me to try the Gorilla 2506 motors. So I threw the 2506 2750 kV on. So, and this is a really good example of what we're talking about, is knowing what you're trying to accomplish and matching your prop and motor to what you're trying to accomplish. So I threw them on my Chameleon, which is a fairly heavy quad. I mean, especially with 38-gram motors on there, that's you're hitting, the all up weight on that is about 650 grams. So, but going into that, I knew what I was dealing with. So I chose those motors and a specific prop intentionally for that setup to get a very specific type of handling. So I wanted to make it as snappy and as instant as I could make it. And so I put the V1S 5x4x4s, which are kind of an odd prop in that they actually produce very little thrust in the low end and very little thrust on the top end. So they're kind of not very little, but it's kind of, they basically take your motor and scale it down by a factor. So I wanted to bring that 2750 kV and that really large stator size under control. And instead of using the power in kV to produce thrust, I wanted it to produce response. Because those V1S 5040 quad blades are insanely responsive. They're very snappy props. They change speed very, very quickly. Some of the quickest of any of the props that I've tested on the bench.
That's interesting. You wouldn't necessarily expect that out of a quad blade.
You wouldn't, but the way the way the torque loading is on those props, obviously the V1S 5x4x3 is a little bit quicker, but only marginally. Like you actually don't change response time much different between quad and tris.
Yeah,
it's very minimal difference. It's actually the profile of the blade and the moment of inertia that has of the blade itself.
Right.
Obviously, you get a multiplication of that when you add 4 blades instead of 3.
The more blades you add, the less I think it matters, because each blade is sort of riding in the other's wake and so forth, especially on the bench, but also a little bit to a lesser degree in the air.
Right. So anyway, I basically intentionally set that up to be as snappy as possible and to bring the current draw and the kind of just raw explosive power of those motors more into something that's manageable in tighter spaces and has a kind of a dynamic range that's easier to work with. And I was very pleased with the results. And it was a quad designed for a very specific, it was a setup designed for a very specific result, and the results were exactly what I was looking for on that. So it that's kind of the example of knowing what you're trying to accomplish, choosing your setup specifically to match what you want out of that quad. And I was just really pleased with the snappiness. I mean, it literally, you can do full stick, stop that thing, and it just stops dead. I mean, there's no play, there's no overshoot. It's just
everybody thinks about tuning, and this was true more in the old days when our motors didn't have just infinite torque and infinite thrust, and now we have such great prop designs, great ESCs with strong braking and so forth. But when power systems were a lot less sophisticated, you had to do a lot more work to get like sharp stops, smooth stops, and to get rid of prop wash. And tuning the PID loop was also way less sophisticated. I'm talking all of 2 years ago. And so you had to do a lot more work with your gear to pick the right prop and the right motor to get it to fly the way you wanted it to fly. Nowadays, I think that's less true because our equipment, our power systems, and our flight controllers have gotten so sophisticated. With a little bit of work, you can kind of get almost anything you want out of anything. It's just how much work are you going to have to do to get there. I'll go back to...
I mean, that's true, but there's obviously physical limits to the... and one of the things that I've noticed, I've been trying a lot of different props recently, like just kind of throwing a bunch of stuff at my quad and seeing how things handled. And one thing that I've noticed is that probably one of the most significant indicators for prop wash is what prop you choose. There are some props that just do not tune prop wash out no matter how hard you try. And there are some props that just kind of almost have no prop wash right out of the gate. So, the kind of the quintessential example of this is a quad that I was working on where I flew the HQ V1S 5048s back to back with the GemFan 5152s. And I spent, well, not back to back, but like they were the two props that I tried one after the other. So I spent a long time trying to tune the prop wash out of those 50 F48 V1S, and they just and I actually ended up talking with some other pilots, and they're like, yeah, you just have to kind of, I couldn't tune it out either. You just have to kind of fly around it,
Yeah,
which
yeah,
is what I did. And it was flyable, but you have to
yeah,
do a lot more work to not
yeah,
fly into the prop wash.
yeah.
So, and then I slapped the 51, 52 gem fans on there, and there was like no prop wash immediately.
Right.
So it just depends. I mean, the prop.
Everybody who's thinking about tuning, like tuning is great. I love tuning, of course, but also changing up your equipment, and even something as simple as changing props, which you might not have the money to try 7 different motors, but you probably have the money to try 7 different props,
Right.
and maybe some of those props will handle a little better than others.
Yeah, it was a very interesting experiment, and of course, then I got a little carried away trying out the tune, and I managed to draw 1,360 milliamp hours out of a
Yeah,
CNHL 1,300 milliamp hour pack in a minute and 25 seconds.
yeah, that's yeah. So
Oops.
then let's go back to the F40 versus the F60. We talked
Mhm.
about the F3 versus the Pro line, and the primary difference between those motors, as we said earlier, is the stator size, 2306 versus 2207, a wider, shorter stator versus a
Mhm.
taller, narrower stator. What kind of characteristics might those motors produce, or what kind of pilot might choose the F60 versus the F40?
Sure. So this is something that I've been like kind of searching after for a long time to try to quantify through data, and it's actually very difficult because there are so many variables. So you can
Mhm.
have a 2306 and 2207 that are, similar, but getting them to be where the stator size is the only variable that's changing is actually extremely difficult.
Sure.
Even if they are made by the same manufacturer and wound in the same place, you're going to have some kV variance between them. So it just.
Well, let's talk about the actual motors that you could buy today rather than
Mhm.
speaking theoretically. In terms of KV, oh gosh, we haven't even talked about these motors probably come in different KVs,
Yes.
but yeah, no, there's like a 2400 and a 2750 of the F43. So, but uh, about the motors you could buy today, the F40 versus the F60, what kind of differences are there?
So, and again, like I said, it's hard to quantify it, but I spent a lot of time talking to a large number of pilots who have flown a large number of motors, and my own flight experience, and the general consensus, and this shows up a little bit in the data, but it's really hard to isolate, is that 2306, the wider stators, and even 2407 is a thing now, and
Hmm.
um, the sunny skies, even though they say they're 23, they're actually 24. So
Hmm.
um, you get some variance in there, but wider versus taller. Wider tends to give you more resolution low in the throttle,
Hmm.
and less of a kind of a rise in the top end.
Hmm.
2207 narrower and taller versus wider and shorter. Narrower and taller gives you kind of, it skips over the low end. It goes kind of straight to the top end, and it just keeps climbing.
The analogy that I used, and I can't remember the motor where I first had this thought, but it felt like driving a car with a turbocharger,
Mhm.
where you kind of, if you ever step on the gas and the turbo takes a minute to spool up, but then as soon as you hit 2200 RPMs, then suddenly,
Yeah,
wah!
yeah.
And so you touch the throttle and not a lot happens, and you continue to raise the throttle, and then all of a
And all of a
sudden,
sudden, boom, yeah.
and so
That's
that's more like a 2207.
right. And 2306 tends to give you more resolution on the low throttle, so you have more control at low throttle, which a lot of people take to mean low end torque, but
Hmm.
it's actually not low
Hmm.
end torque. The 2207 actually tends to have more low end torque. That's what
Hmm.
makes it kind of skip over the low end of the throttle, in that it just ends up going to high RPMs very quickly. Um,
It almost sounds like you're saying that the 2207, because it has more low end torque, is more responsive in the low end. And therefore, as you raise the throttle, it's just like, yeah, I'm with you.
yeah,
Whereas 2306 with a little bit less low end torque, as you move the throttle, it responds just a little slower, but in a sense that smooths out your stick motions a little and
yeah.
gives.
It's hard to quantify exactly how all of that works. Um, but and some of it has to do with where in the torque loading, where the RPMs kind of generate the most torque between the two.
Mhm.
It's a very complex kind of relationship between everything. One thing that's interesting is that the wider stators seem to do better on heavier torque loaded props.
Hmm.
Whereas the
Yeah.
2207 seem to really like the props that are going to hit those high RPMs.
Right, the lighter props.
So
Yeah,
it's
I've noticed that too. The 2306, the wider motors seem to like the heavier props. I don't really even ever run like 50/50s. That's just not my style. But say even something like a 50/46 versus a 50/40, the 2207 Finexes, they'll push a heavier prop, but they seem a
absolutely.
little happier on a little bit lighter prop. And frankly, even as I was saying earlier, even a wide thin motor like this or stubby motor, it did great. Um, but but
Yeah. So, and again, it depends. It depends on what you're looking for and how you're expecting it to fly. If you're going to do more like proximity type flying where you want control,
mhm,
the 2306 is probably better for you. If you
mhm,
want something where you're going to hit the throttle and you're going to leap across the entire football field, then the 2207 might be the thing for you. If you're doing if you're doing mountain cruising,
right,
2207 is probably going to be more your thing than 23 whatever,
mhm,
or 24 whatever. Whereas if you're doing more like controlled, proximity where you're shooting small gaps and you're wanting to have that control, then 2306 might be your thing. And again, if you're racing, it's a similar thing. Are you spending a lot of time in the top part of the throttle on your race?
mhm,
2207 is probably going to be better for you, or taller stators are going to be better for you.
mhm,
Are you one who's doing the smooth lines? Are you following through and spending more time lower in the throttle and then using the top just to boost
mhm.
when you need to recover? Then the 2306, or whatever the wider stator may be your go-to. I do feel like there's a minimum height that's necessary for a given width to be effective.
Mhm.
I see a lot of people pushing out like 2405 or some of these wider stators that are really quite
Yeah,
thin. And
pancakes.
yeah, exactly. And I don't. I mean, you see them. I think that if you're going to use those types of motors, you have to be lower, much lower in the RPM cycle.
Yeah.
Um,
It's
really,
traditionally very low RPM motors, high torque, low RPM motors for very big props have been that style, really wide, really, really short. But that's not where we are with what we're doing with our props and our quads.
right, right. So it's I think that if you're looking for a particular RPM range, there is a minimum height that's capable of sustaining those types of RPMs effectively. And if you go below that height, then you kind of start losing efficiency and losing the ability to even reach effectively those kinds of RPMs.
So let's I see that we're coming up on your stop time, and we've probably lost all our viewers if we've gotten bored and tuned out. But no, I'm sure they always surprise me with how interested they are in this, nerdy geeking out. Let me close up with a couple of quick questions. Is 2206 dead?
I mean, it goes back to balancing power, weight, and handling. I think there are still situations where 2206 is applicable. The reason why it's kind of disappeared, I think, is because we've managed to get 2207 motors light enough
Hmm.
that you can fly a 2207 in the same space you would have used to fly a 2206 and get more torque, more response, more RPMs.
And with the design of the motor being designed correctly, not necessarily more amps, not
Right.
necessarily efficiency.
Obviously depends on how you're using it. And um,
Yeah, I feel like 2306 is kind of the new 2206.
yeah,
Used to
I
be if
agree.
you
People
wanted a
who
performance motor, it'd be a 2206. There just were a jillion of them. I recently went looking for a good 2206 to fill a spot on my Ultimate FPV shopping list, and I kind of couldn't find one. I mean, they're
right.
out there, but not as much as they were. Everything now looks like it's 2306 and bigger.
And I think the style of flying that kind of lent itself to 2206 is the same style of flying that is going to benefit from a 2306.
Hmm.
So I think that 2306 makes sense for those pilots, especially given the weight is essentially the same. So, we're looking at 2306 motors that are not that different
Yeah.
than the old 2206, but do a better job of hitting the requirements those pilots are looking for.
Yeah, I might have done myself a disservice by making the Emax 2306 2700 kV my first 2306 motor, because that one was just an absolute battery killing beast. And in a sense, I thought, yeah, see, 2306, big motor, battery killing beast. But it's definitely not the case. When I flew the T Motor F40 3 at 27, I think it's 2750 kV, it was a really manageable, very nice motor.
Hmm. Hmm.
And I never would have hesitated to run like a 2206 2700 kV, especially before N52 magnets became a thing. That was a totally manageable motor. It wouldn't fill your batteries. But no, the right 2306, or heck, this 2407 wasn't even really that bad.
Those are the 2500 kVs.
Yeah, they're
Mhm.
2500. Yeah, it
Yeah, and
wasn't.
that's a pretty light loaded prop on that motor. So
Yeah. So yeah. Um, in fact, I think you're going to test the RCX 2306 soon, or maybe you already
they
have.
said they were going to send it, but my RC Mart is kind of
Mm.
an interesting company to deal with because they don't really seem to care about the normal like things people care about, like
Like reviews.
end customers. But
Yeah.
I mean,
But we were talking about this. They make a really good motor. In fact, you showed me the thrust and response curve of the RC, was it the 2206
yeah, it was the RS 2206 version 2,
against the hype train,
2400 kV.
against the hype train,
Hmm.
and they
And
were
they were
like
almost identical.
identical.
Yeah.
And I was like, we can't let this get out, because why would you buy a hype train at that point?
Well, I mean, I think there's still reason to, it depends. There's a lot of factors that go into motor choice, and the RCX is a good
Both
motor, but
awesome.
there's availability problems sometimes depending on whether they have them in stock or, you know,
Well, I mean, come on, Rotor Riot's kind of they're not exactly the best when it comes to keeping
wha-
stock. No offense.
true. Honestly, I don't pay that much attention, but
I knew we get grilled for that if I let that slide.
you're dealing with China, so you've got 2-week delivery time, sometimes more, depending whether it's holiday season. So I mean, yeah, it's a $9 motor, and they're actually surprisingly good build quality. And
I'm hoping that the 2306, they have generally there are a few black marks where they had a bad run,
Mhm.
but in general, RCX motors, you actually first recommended to them years ago. You recommended them to me.
Mhm. The old
And
H2206.
yeah, they've had great performance, reasonable durability. I hear it's gotten better, and it sounds like their performance now is on par with much more expensive motors. And I hope their 2306 is an absolute rock star.
Yeah, and I think the one difference between the
Motor.
20 the like for instance, even though the throttle curve is basically the same,
Mhm,
the hype train, because of the way it's designed versus the 2206 really pushing the limits of the stator size,
mhm,
the 2306 is going to be a little bit more conservative in terms of current draw.
mhm,
So you're going to reach RPMs with a little bit less current.
mhm,
So like I said, there are definitely reasons, even though the response curve is essentially the same.
mhm.
When you start digging into the design parameters, there are reasons to go with a 2306 versus a high-end 2206.
Yeah. Cool. Well, I think that's a good place to wrap up. I hope that we can do this again. I really enjoy these conversations. I hope that people will leave down in the comments things that you'd like to see us talk about in the future, and maybe we'll talk about them. Thank you very much for being here, Ryan.
Yeah.
Again, I'll plug your site, miniquadtestbench.com, motor and sometimes ESC, but not so much ESC testing. And definitely, if you go there, don't just look at his reports where he writes up them and look at them too, but he's got a data explorer where you can pick individual motors and put graphs on top of each other. And if you're a data geek, it's really heaven. So
I spend a lot of time there myself.
yeah, I know we make these tools for ourselves
Well,
first and foremost.
exactly. I built that for me.
Yeah. All right. Well, we're going to sign off here. Ryan, thank you again. Happy flying, everybody.